Hi, today we're going to have a very interesting topic on quadratic functions. And today we're going to deal with the roots of any quadratic equation. So for problem number 1, we have here, find a quadratic equation whose roots are the squares of the roots of this equation here, 4x squared plus 8x minus 5 is equal to 0. And we know that the general formula for any quadratic equation is ax squared plus bx plus c is equal to 0. And since we are given this equation here, 4x squared plus 8x minus 5 is equal to 0, R1, the first roots and the second roots, the sum of the roots is equal to negative b over a, where b is the coefficient of the second term and a is the coefficient of the first term. So negative b is negative 8. This will become negative since our relation is negative b over a. So negative 8 and a is 4. So simplifying this fraction here, we get negative 2. For the product of the roots R1 and R2, we have this relation c over a, and c is the constant, the third term, which is equal to negative 5, and a again is the coefficient of the first term, 4. So we're going to use this relation here in finding the squares of the roots. This is not the final answer yet. So please be careful with understanding the direction. Since we are asked to find the squares of the roots of the equation, we know that R1 plus R2, if we square that, if we square the sum of the roots, that will be equal to square of the first term, R1 squared, plus 2 R1 R2 plus R2, the square of the last term, R2 squared. So to get this R1 squared plus R2 squared, we need to get rid of this second term. So we're going to subtract from this product, or from the expansion of this binomial here. We're going to subtract 2R1 and R2 so as to get R1 plus 2, so as to get R1 squared and R2 squared, plus R2 squared. Doing that, since we have already taken the sum of the given equation to be R1 plus R2 is negative 2, and R1, R2 is equal to negative 5 over 4. We just need to substitute these two values here in our equation. So to get R1 squared plus R2 squared, since we know already that R1 plus R2 is equal to negative 2, and then we're going to square that, and negative 2, R1 and R2, since we have found out that the answer is negative 5 over 4, we just need to substitute. So that will be equal to negative 5 over 4. So continuing this, the solution to this equation here, negative 2 squared is 4, plus, since negative is positive, so 2 times 5 is 10 over 4. So getting this simplified, so we have here 4 times 4 is 16 plus 10 is 26 over 4, and simplifying again this, that will be equal to 13 over 2. And R1 R2 squared, R1 R2, the product of these two roots here, and squaring that, we have here negative 5 over 4, as we have computed already, negative 5 over 4, squaring that, we get 25 over 16. So we now have this relation of these roots to the quadratic equation, which is x squared minus the sum of the roots r1 plus r2 squared, r1 plus r2, x plus r1 r2, no? So this one is let's make some corrections here. So this one is square, no? And also this one is squared, no? And this one is equal to 0. No? This one is equal to 0. So we continue. Just substitute, no? The values of r1, r2, no, r1 squared plus r2 squared, which is 13 over 2, x, no, plus r1, r2, which is r1, r2, which is 25 over squared. No, so this one is squared, no? So this one, we're going to square this also, no? So we have here x squared minus 13 over 2x plus 25 over 16, that will be equal to 0. Now we get substituting these values that we have obtained. No? So the LCD is 16. Multiplying the whole equation by 16, we have here 16x squared minus, no? 1 over 4, so 16 divided by 2 is 8 times 13 is negative 1 over 4. So 25 over 16 times 16 is 25. So the whole quadratic equation is this one, no, is equal to 0. So this will be our new equation. No? And this equation, the roots of this equation is equal to the squares of the roots of the given quadratic equation. So let's check. No? This is our given quadratic equation. 4x squared plus 8x minus 5 is equal to 0. We get the roots. No? The roots is 2, the factors is 2x minus 1 and 2x plus 5 is equal to 0. So getting the roots, no, the first x, no, the r1 is equal to 1/2, no? And this one, the roots of this second binomial here is negative 5 over 2. So squaring, no, the first roots is squaring 1/2 is equal to 1/4, and squaring this r2, that will be equal to 25 over 4, no? 5 squared over 4 over 2 squared is 25 over 4. And then substituting, no, these two roots, no, x minus 5, no, the first roots, and x minus 25 over 4. Now we expand this one, so 4x minus 1 and 4x minus 25. So if we expand this into a quadratic equation, we're going to get 16x squared minus 1 over 4 x plus 25 is equal to 0. So our answer is correct. No? So we have another problem here, another interesting problem here. Find a quadratic equation whose roots are the reciprocals of the roots of the given problem. No? 4x squared plus 8x minus 5, no, is equal to 0. So we're going to use the same equation, no, so as to understand this fully. No? So the reciprocal of the roots is 1 over r1 plus 1 over r2 is equal to r1 plus r2 over r1 or r2. No? So we have this relation here. So 1 over r1 plus 1 over 2, no? So since this one is r1 plus r2, so we have already found the values of r1 plus r2 to be negative 2, no, or negative 8 over 4. So we just substitute negative 8 over 4 and c over a to be, which is r1 r2 is equal to c over a, negative 5 over 4. Simplifying, no, this fraction here, no, a little complex fraction, we have here, we cancel out 4, we get 8 over 5, no, positive 8 over, since negative over negative is equal to positive 8 over 5. 1 over r1, r2 is negative, the reciprocal is negative 4 over 5. No? So we just substitute these two given answers. No? We have here x squared, so our new b, no, our new coefficient, which is minus 8 over 5 minus 4 over 5 here, no, since the value is here, is negative 4 over 5 is equal to 0. So we multiply the whole equation by 5, so we're going to get 5x squared minus, no, cancel out 5 here, we get negative 8x, and this one here for the term, negative 4 over 5 times 5 is equal to negative 4 is equal to 0. This will be our final answer. So that's it, no? That's how we're going to get, we're going to solve this particular problem here. So please, thank you for watching our videos for today. No? Please don't forget to subscribe to my YouTube channel by Quadratic. And if ever we have some comments to just improve the quality of our teachings or instructions, please do so. No? And also don't forget to click that notification bell. So thank you and see you again later. Bye-bye.